So now we've considered the current and we spoke briefly about the output also, speed and torque, that is related via the conversion factor. Uh, what is the starting and stalling torque? Like, is it a,
Okay.
how do you measure?
Yeah, so there is this like a curve relating torque and current. While starting the motor, you require a higher current,
Okay.
the starting current, and stalling refers to the current when you're not moving the motor. I mean, you're giving it power, but it's not moving.
When it's
So
idle?
for example, it has a load,
Oh, okay.
so it's not moving, but if you're feeding it with current,
Okay.
so there is a
limit.
limit. Yeah, there's a limit before it fails.
Okay.
These two currents.
Okay. So and there is coming back to the power source. There is something called power density, right?
Yeah.
What is power density? How do you measure it? Is it just the power needed for?
Yeah, it's more about related to efficiency in motors.
Okay.
How it takes the incoming energy to the output.
Okay.
But yeah, DC motors actually have a good power density. Yeah.
Okay. So you spoke about brushless DCs being better because the brushes usually have wear and tear.
Yeah.
Are there any other components that also undergo wear and tear? And are there I think the bearings undergo wear and tear?
Oh yeah, also.
So is there a way to reduce that? I mean, do any of the motors, are they better in some way such that, like brushless DC is better because it doesn't have a brush? So like that, is there any other motor which can?
Well, yeah, it also kind of depends on the application. There is, for example, the stepper motor, which is also electronically commutated, but it comes into small steps.
Okay.
It's also used in bioengineering, for example.
Okay.
Or regular motor with servo control, so it's for adjusting the speed in an efficient way.
Okay.
So yeah.
So those can be brushless or with brushes?
Now that these are usually regular DC motors with brushes.
Okay.
The VLDC are another type of motor.
Okay.
Yeah.
So finally, for a robot actuator, how do you decide that okay, fine, brushless DC might be the best option? What are the? I mean, you've explained all these things separately, but if you can sum up in a brief description.
Okay, so first is choosing between AC and DC, which as I said before is going to be DC almost all the time. Then the second and I think the most important is the power consumption, because that decides on the size of the motor. And then depending on the application and the money you have as well, it comes the choice between brushless, stepper, or as I told you with the servo controller. That's application dependent.
And does it, you spoke about price, are the variations a lot depending on the size and all that? Or?
Yeah, for example, comparing a DC regular motor with a brushless motor, the brushless motor is more expensive because of the electronic controller. It increases the price, but in a long term you will reduce it because you are not coming into regular maintenance to change the brushes.
And is there a quality certification or something like that?
Well, yeah, there are like knobs, but I think it's not that important. It's more into the power.
Okay. Then if you can tell us any of the manuals or literature that we can refer to for some of the values, standards, and those kind of things you do?
Okay, well, there are a few available in the internet or some books, but I think a good one is Brochure Incorporated. There is an overview of the manuals and it contains all the specifications related to a motor selection.
Okay.
I think it's a very good guideline.
Thank you, Hugo. I think that's the end of our first knowledge station interview. We'll be sending you some of our decision trees and inference diagrams and those kind of things.
Okay.
We'll discuss with you in the next interview about some of the details of the infrastructure. And
Okay. Thank you very much.